My name is Phoebe. I am the program manager of the voice team at Gridspace, but I'm here in my role as alumni and recruiter for MIT. So I am on Killian Court in front of the Dome, reliving the glory days. And we have just finished up a weekend's worth of interviews after the career fair in the fall. So it's always nice to be in Boston in the fall. I thought whilst I was here, I would record a little thing about just, it's amazing when you're interviewing people how much you realize you learn in the workspace, and how much I wish, how the little things you wish they actually taught in school that are just different from the theory in classes to like actually putting that into practice in industry. So I just thought I'd cover like 3 things that come top of mind as to things I wish I'd learned at MIT. And the first one is kind of scale. So for machine learning engineering, when they teach that in classes, they tend to teach it with like a toy data set. So something small and manageable. Obviously you're bounded by like computational resources in a class of like 20, 30, 50 people. And also time, you want to be able to like teach the modeling aspects. You don't want people to get too stuck on processing, like difficulty in computational limits of processing large files or large data sets. But when you then get out into industry and you realize that all the data sets are huge and require a lot of pre-processing, then the actual processing input pipelines way of managing the data and the memory so you don't store it all in RAM at once is actually a huge part of any ML engineering. So I wish they covered more of kind of how you parallelize that, how you work with existing libraries to parallelize and optimize pre-processing steps for large data sets and large data files when you can't actually split one file across multiple, and how they're stored. So things like ragged tensors, TF records, those kind of data storage formats and processing, beam pipelining, those are things I wish they covered more of in school. On the same kind of topic, the second thing I wish they covered more of was that kind of data pre-processing. So, and data debugging. Quite often in classes, you're given a toy data set, you're told what kind of features it has in it and what you can train on. In the real world, you are given, let's say, raw audio for speech. Gridspace, we specialize in speech, and so a raw audio file has a lot more information in raw format than anything that we typically see in a kind of pre-packaged class data set. And so obviously there's a lot that comes with that in terms of working out what you're going to do to pre-process and realizing that whatever you train your model on is what it's going to learn. So I reckon if there was some more emphasis on exploring different forms of pre-processing with the same model, instead of tuning hyperparameters, which they kind of do make you experiment with somewhat arbitrarily in class, I found, I wish they had us tune data sets and see the different things that a model can learn depending on what you actually give it. So that's the second thing I wish they taught a little bit better. And alongside that, just like ways of data debugging. So like looking at distribution, using Jupyter notebooks to visualize your data, really understand what's in there before you start training. And understanding then there's going to be bias, there's going to be things that you don't learn so well, things that you learn better, and ways to focus a model depending on how your data set is skewed. So then the third thing, which again is somewhat related, the third thing I wish they taught was more of the kind of data conglomeration and feature engineering. So again, you get given these raw audio formats and you want to be able to extract out the features you want. And again, we quite often get these toy data sets which have them already specified, or you can do a little bit of pre-processing, but there's not that much you need to do. And also the output vector space, and the output, the format of the output is quite often pre-specified for you. Whereas in real life, you have to decide and design what your output features are going to look like and how you're going to train your model to learn how to output things in the correct format. And also with, like, there are obviously some paradigms that are pretty established and work better than others, but a lot of it is down to choice. And again, you can train a model to learn most output formats. Do you want it to be a one-hot? Do you want it to be a softmax classification? Do you want to be able to extract multiple, or are you going for just like a single classification? Are you going for more of an output vector? There's so many different ways you can choose that your output is formatted, and I don't feel like we are taught in class that most of them are valid. And it does again come down to design choice. So feature engineering on the output space is actually something I think is undertaught in classes. So you might notice that there is a common theme throughout all of these things, and they're all data oriented. I think there is not enough data engineering taught in ML classes in colleges. So that is my 2 cents of what I would love them to teach more of in classes, and I'm going to leave it at that. Thanks.